And then here is everybody. We also have somebody listening on audio. All right, everyone, thank you for coming. Thank you for giving me the opportunity. My speech is going to be about nuclear power. Whenever I think of nuclear power, I think of it as a future energy source. Whenever I think about it, I look at the sun. I look at literally the sun. Whenever we're having the future of energy, it's like literally bringing the sun on Earth and using that. Whenever I think of nuclear power, I see opportunities that oil had and all the things that oil, how it changed our entire world. I believe that nuclear energy and specifically fusion energy will also bring that. Nuclear fusion, to me, is the greenest so far power that we have, mainly because of the fear of CO2 emissions. When a successful attempt of nuclear is actually created, I think it will be the best that we have. My name is Ian Howing. I am a Northwest Community College student. Right now, I'm in my associates for machining, precision machining and manufacturing. I'm also studying metallurgy. The main problem with nuclear fusion that we have now is that the technology that is being used to create the reactors is the same technology that they used in the 50s. It's the exact same technology. The confinement process for containing the nuclear plasma is the same method that they used in the 50s. Mikhail Chudnik, the IAEA Deputy General and head of Department of Nuclear Energy, and Aldo Malvasi, IAEA Deputy General and head of Department of Nuclear Science and Applications, did a fantastic job of elaborating to me exactly the differences between fusion and fission energy. Fission typically is a non-natural process. The way we get energy out of fission is we take uranium or plutonium, or we refine it, put it into rod form, stick it into water, heat up that water, make it into mist, and it spins a turbine. The process for doing fusion is we have to produce deuterium or tritium, and with that, we fuse the two together, and seemingly the most likely way that we'll get energy from that process will be thermal conversion, just like with fission. And this is because when in a fusion process, 80% of the particles that are released are high energy neutrons. Those type of neutrons are not capable of being converted in any sort of energy source whatsoever. So the likelihood of being able to use fusion as an energy source solely comes down to perfecting the process, because the rest of it is already set up. All the other power plants on the Earth use the same type of process to make electricity. When it comes to fusion reactors, just like I said before, the method of confinement of the nuclear plasma is the same. They're all the same. They all got a bunch of different fancy names. There's stellanators, tokamaks, multipoles, Z-pinches, theta pinches, baseball seam coils, yes, and the Astron. The only difference between each of those is the style at which the team designed the magnetic field to confine the nuclear plasma. The only difference is the way they decided to put it together. It's all electromagnetically confined. Even large governments and organizations still think nuclear fusion is and the method that we're still doing it is still viable. Michael Kozol, an associate editor of IEEE Spectrum, says that NEPA researchers have reopened their cases for cold fusion and low energy fusion. And Brian Bergstein, the executive editor of MIT Technology, says that France is putting together a 60 soccer field sized ITER, which is a form of tokamak, to hopefully overcome the previous problems with the tokamak style of reactor. Daniel Jaspy, a PhD in astrophysics, the principal researcher at Princeton Physics Lab, and has had over 25 years in plasma physics and neutron production, undermines the whole industry for making nuclear fusion the same way they tried to make it back then, with two very simple points. Points that I made earlier. 80% of particles produced are high energy neutrons. These neutrons do nothing that we can use. You can't, how did you put it? They do damage, they do severe damage to the reactors. So you have to have the confinement be shielded, which makes the production process more expensive. And also the neutrons cannot be directed to possibly have a direct conversion be done to make energy. And then also the electromagnetic fields that are used to confine it are almost take up the entire energy source that the reactor makes in the first place. So the parasitic consumption of energy is wild. I have to when I looked up all this, I had to bring myself all the way back to the very basics that I was taught in high school about physics. In a closed system, you can't create energy from nothing, right? If the type of energy that we're creating is from an electromagnetic reaction, then you can't use that same energy to then confine the reaction. The method, the idea for doing this doesn't add up. And all in all, though the understanding of nuclear power is very limited today, I really do think that the potential for it is as great as ever. Thank you.
Thank you. Just on time. Awesome.